Hi everyone, let's do a walkthrough of the framework. So let's start with RunMe. I'll probably rename that to Test Perceptron before I give it to you. This is kind of the main class where you can test to see if your classifier is working, and it's a good place to see what methods I'm providing to you. So let's start with the creation of the data set. I have a data reader class here that has a static method called createDataSet from CSV. The file path is iris.data, which you can see here, and this has the 4 data features that we described plus the class for that data point. These headers are the titles for each of the columns. So the first column of numbers is the sepal length, the second is the sepal width, and so on. Okay, so where we actually build this perceptron is here on line 13. So your perceptron needs to take 2 parameters in its constructor. How many inputs the perceptron is going to use in its classification. So in other words, this is like the length of the feature vector that you're going to feed into it. And then what kind of classifier your perceptron is. So I've defined a constant up here called Virginica. So I'm going to try and classify Virginicas. Obviously, you could change this to other iris types if you wanted to classify other things. So I am running the training data, so that's training the perceptron, and then I'm going to test the perceptron on the data. Right now I'm doing a really serious no-no later on for neural networks, which is I'm training the perceptron on all of the same data that I am testing it on later. That's a really serious mistake later, but for now it's okay. So let's look at the test part right now. So the way we're going to test the perceptron is we have our data set D, and we're going to loop over all of the data points in the data set. And what we need to do is we need to have our perceptron make a guess right here. And we give it the feature vector as input. So how do we get the feature vector? Well, each data point here has 4 possible dimensions, the 4 possible features. But remember, my perceptron up here, when I created the perceptron on the number of inputs, the number of inputs is features.length, and here's features. So I'm trying to have my perceptron only use 2 of the features, only sepal length and sepal width. So I'm creating it with 2 inputs. And what that means is down here, when I'm training it, when I tell it to guess something, the input vector I give it can only have a length of 2. Otherwise it will, I don't know what it will do. It'll either crash or it'll tell you can't do that. So I've made a convenient getter method for you. It's called getData. So you can give it a string, an array of strings for which are the actual features that you want to include in your input. If you want to, you can also pass it as many arguments as you want in order. So I could say sepal length and sepal width here, and it will return an array that contains this number followed by that number. I did a clever thing which lets you actually put as many parameters as you want in this list. And you can look in the code if you're curious how that works. Okay, so the output of the guess is an integer. And remember that integer 1 we're using to mean that it's predicting that that feature vector does represent whatever we're trying to classify. 0 means that we're predicting that it doesn't. So if I wanted to check if I was right, I could do something like this. I could say if the guess was 1, and also the correct label for my data point, which I get up here, I get label string. So if the correct label equals what my thing is trying to classify, a Virginica, then I know that I got it right. But actually that's not totally correct, because there's another way I could get the answer correct, which is if my guess was, my parentheses are all going to be messed up now. If my guess was 0 and the label isn't what I was trying to classify. So there's kind of 2 ways I could be correct. So guess equals 0 and correct label equals what to classify, but doesn't equal what to classify. So those are the 2 ways I could have gotten the answer correct. That all seems very awkward, so I went ahead and made a helper method for you where you can just ask the neural network if your guess is correct. So you give it the guess that your neural network made, and you give it the correct label for the data point that you were trying to guess. And the neural network which knows what it's trying to classify, just checks to see whether its guess was correct. And if you want to follow in here, well, I guess I'm doing a more complicated thing, but you can sort of see it. So that's the high and the low about how it works. Down here in run training data, I have a bunch of loops called epochs, and we'll talk more about that later. But I'm looping over all of the training data. I get the correct label out of each data point. Then I get the feature vector that I want to be using, and I tell my neural network that I want to train it on that feature vector. But I also tell it what the correct answer that it should expect to get is, because that's how training works. So that kind of summarizes the things. And you have to implement train, and you have to implement guess. And I think that's it. But before we do that, let me show you a different part of this framework that might be interesting to you. If you go to main actually includes some nice visualization. The visualization won't work unless you're only using 2 features, because it's based on a 2-dimensional representation. But if I run it, you'll see what's going to happen. So in the upper section here, it displays the equation that the perceptron is currently using. So it's going to take the petal width and multiply it by a weight that's initialized to 0, and add it to the sepal length and multiply it by a weight that's initialized to 0, and then test if that's larger than this threshold, which is 0. The 2 dimensions here, you can imagine this is a graph where the x-axis is petal width and the y-axis is sepal length. And this is all of the points in the data set. Well, all of these guys here in the middle. All of the rest of them are kind of imaginary irises that we're going to ask our classifier to guess about, but it's just so that we can easily see where the decision boundary is. So right now, if the interior of a point is green, that means the classifier is currently correctly classifying those examples. And if the interior is red, it means that the classifier isn't. If the circle that surrounds the interior is purple, that means it is, I forget what, let's look. Okay, so purple means that it is not the category we're trying to classify, and yellow means that it is. So in our case, yellow means Virginica, purple means not Virginica. So you can click, and each time you click, it runs through the training data. So you can see that the weights are slightly adjusting. Yours won't do that because you have to write your training first. So I clicked a couple of times, and you can see this kind of boundary here. This is the actual decision boundary that the perceptron with these weights is using. So everything below this line, our perceptron is predicting is not a Virginica. And that's why you can see that all of these purple not Virginicas are green, because we're getting that right. But all of these yellow Virginicas are red because we're getting it wrong, because all the yellow Virginicas are in this kind of shaded region where we're predicting it's not. So if all has gone well, you can click a bunch of times, and eventually, as you can see, I've trained my network to discover a decision boundary that's correctly classified both kinds, and I can actually see what the weights and the threshold are here. So that's kind of a nice tool that you can use. But again, the visualizer only works assuming that you have an input feature length of 2. The last one that I made, and I haven't really cleaned it up, so it's kind of ugly, is this Perceptron Visualizer, and it looks like this when you run it. So it has this kind of visual representation, and again, it's only designed to work assuming that you're using 2 inputs. But you can use the arrow keys to go up and down, and you can see what are the 2 input features, and then what are the weights, and then how does it combine, and what's the threshold we're using. And then we can see what the actual perceptron is predicting. So these green circles are ones that we're correctly classifying, and the red ones are ones that we're not. So if you go to a red one and you hit T, it will train your classifier just on that single data point. So you can see the one that I trained on has now started to become classified correctly, but ones that used to work are now broken. So you can kind of go back and forth and train and not train. Oh, I'm actually going to probably show you this in class, so I don't need to talk about it anymore. Anyway, this thing exists, and you can use it.